All right, Ms. Whitaker here again, and we're going to continue with the part of your review that deals with 7.4b, which says graph data to demonstrate relationships in familiar concepts such as conversions, perimeter, area, circumference, volume, and scaling. So this is where we're going to be dealing with a bunch of graphs, and we're going to look at relationships in all these different concepts. So let's just dig in and see if we can look at these tables and look at these graphs and interpret the information they're trying to tell us. All right, this says the data in the table below represents the relationship between the length of a side of a square. Here's the length of the side of a square in centimeters, and the area of the square in centimeters squared, which is going to be our y. So here's our x and here's our y as is labeled here. So don't miss the little things. Just really study this. Now let's just make sure this makes sense. These are squares. Here's the length of my side. These are all squares. So if the length of the side is 1 of my square, then 1 times 1, the area is going to be 1. If the length of my side of a square is 2, then 2 squared is 4. If the length of my side of my square is 3, then 3 squared is 9. 4 squared is 16. All right, so now that we understand, here's the length of my sides here. Here's the area of the squares with those side lengths on the right. It says which graph best represents the data in that table above. So I'm looking at a graph that has the relationship that I'm looking for of the length of the side of the square to its area. All right, now let's look at our graphs really carefully. On all these graphs, it has the length of the side of the square on the bottom and the area right here on the top. So let's look at this first letter F. When the length of the side was 1, the area was 1. Now that's true, but when it was 2, it was 4. So this next point should be right there. If the length is 2, this should be 4. So this cannot be it. Now let's move to letter G. Now this has 1 and 1, and this has when the length is 2, the area is 4. When the length is 3, then the area is 9. When the length is 4, the area is 16. This looks like a good one, but I'm going to check the others just to be sure. When the length is 1, I should have a point here. I should have a point here. I should have a point here. Now remember they said this is our x value, area was our y value. So it looks like G is going to be my answer, but just to be sure. I can't really tell. It's hard to tell in letter J. It looks like they're trying to make a line over here, and that's certainly not going to be representing the table. So G is my answer. It's got all my points. It has the length of the side, and then with the length of the side a certain number, then the area that corresponds, it has it graphed correctly. So look at all your graphs very carefully before you make your choice, and make sure you looked at all the others and you ruled out the others for good reasons. All right, let's look at the next one. The data in the table below shows the relationship between temperature readings in degrees Fahrenheit and degrees Celsius. So please make sure you note that the Fahrenheit degrees is going to be X, the Celsius degrees is going to be Y, and they have it here. Let's make sure we see. If we were going to plot those points, this is what it would look like. Our X's go first, and then our Y's. So this is the graph that we're looking for. With these coordinates, these ordered pairs, that's the one we're looking for. All right, let's see what we've got here. See, 32, 0. So 32, 0, I should have a point right there, shouldn't I? This says that the degree Celsius is 32, so that's kind of backwards. So that's not going to be it. I can just kind of look over here at C, and already I'm seeing that I think this one's it. I think C is going to be it just by looking at it, but I'm going to check the other ones just to be sure. But this one on letter C looks to be like I'm graphing the ordered pairs that I want, the coordinates that I want. This is not going to give me what I want. This is not a one-to-one relationship between degrees Fahrenheit and degrees Celsius. so that's not it. And this says when my degrees Fahrenheit are 32, then that's for all degrees Celsius. That doesn't even make sense. So yes, my answer is right up there on C. Just make sure that the data in the graph matches what you see in the table. All right, let's move on. It says, which of the following relationships is best represented by the data in the graph? So let's look at this graph. What do we have? We have a 1 to 12, a 2 to 24, a 3 to 36. So we have a 1 to 12 relationship. So let's look at which one of these answer choices would be 1 to 12. That would match that graph. So we're looking for a match. Feet to inches. How many inches in a foot? It's 1 to 12. Already, I think this is my answer, but don't stop at the first answer choice. Go miles to feet. All right, miles to feet, I think there's 5280 feet in a mile. That is certainly not 1 to 12, so that's not it. Feet to yards, 3 feet to 1 yard. That's not it. Inches to yards, well, if there's 3 feet in a yard, that means there's 36 inches to 1 yard. That's not it either. I am positive of my answer. It's 1 to 12, which is what I'm showing here. So this should be the feet on the bottom and my inches on the side. It's a 1 to 12 relationship. That's what we're looking at, is a relationship of the different units. All right, let's move on. It says the table below shows the different sizes of square gardens Charlie can build. So these are all square gardens, square garden sizes. Please understand what you see in the table. Here's garden W, X, Y, Z. I have 4 different garden sizes. Side length of 5, that area would be what? If I have a square and the side length is 5, the area is 25. I'm going to make another, let's just make another column here on our own. So the area is going to be 25 here. Let's see. Oh, and I need to have another one too, because then I look down at my question. It says, which graph shows the correct relationship between the side length and perimeter of each square garden? So I don't even need area, I need perimeter. So when my side length is 5, what's the perimeter of it? It's 5, 5, 5, and 5. So the perimeter is 20. When the side length is 10, then it's 10, 20, 30, 40. My perimeter is 40. When the side length is 15, where'd it go? Oh, it just disappeared on me. All right. Interesting. Let's just start that over. All right, when side length is 5, then perimeter is 20. Side length is 10, perimeter is 40. When side length is 15, it's going to be 60. When side length is 20, 20, 40, 60, 80. So there's my perimeter, and I'm going to choose the graph that matches a side length to its perimeter. So make up, oh, there's the other stuff. So you can make those your ordered pairs. So when side length is 5, the perimeter is not 5, so I know it's not this one. Let's go ahead and look at C while I have it here. When side length is 5, the perimeter is 10. No, that's not it. It was 5 to 20, so this one's not it either. I'm absolutely positive, so make sure you understand we're positive about this. This isn't. We're not just faking it here. All right, letter B. 5 to, well, that looks kind of like it could be 20, but I'm not sure. I know it's not 10 to 100, so that's not it. So before I even look at D, I'm hoping this is it because I've ruled out the other ones for good reason. So 5 to 20, that's right. When the side length is 5, the perimeter is 20. Just look at what we're talking about. A side length of a square is 5. That means the perimeter's got to be 20. When the side length is 10, the perimeter's 40. So this is a relationship. This expresses that relationship that we're looking for. So please know what you're talking about, know what you're looking at, and use your common sense. This is just a square and perimeter, you know how to do that. So make sure you evaluate every answer choice. All right, next question. Let's see if I can get rid of this writing up here. Oh, it's going slow. Okay. 2009, number 14. Oscar made a scale drawing of his backyard. Scale drawing is a drawing that's made to scale of the actual backyard, so everything's going to be proportional in the drawing in the actual backyard. In his drawing, a ½ inch represents 5 feet. So which graph best represents this relationship? So a ½ inch represents 5 feet. So what does 1 inch represent? If a ½ inch represents 5, 1 inch, I'm doubling that. I'm going to have to double this. Represents 10 feet. So that's what I'm going to go with. I'm going to find a 1 inch represents 10 feet. 2 inches would be 20 feet. So that's what I'm going to go with. Now I still could use this scale, but this scale is a little bit easier for me to see. So 1 to 10. Already I see in letter F that's not it because that's not 1 to 10. This is not 1 to 10, so it's not H. So let's move it down and see what we've got down here. I have, excuse my X's here. I don't know, it's acting up. That is so strange. Anyway, I do see 1 to 10. I see 2 to 20. This looks like it's going to be it, but I'm not going to choose it until I've ruled out all of these. This is not it. Should be 1 to 10, but then it's 2 to 20, so it should be an incline like this. So G is my answer. Make sure you evaluate each one. Now I changed the scale. You don't have to change the scale. You can just be looking at 1/2 inch. Here's your 1/2. That represents 5. That means 1 inch would be 10. So that's still your answer. All right. Any more? No, we're done. Okay, let me know if you have any questions, and that is about relationships. Just again, look at the questions carefully, look at the table, look at all your information carefully, make sure you know what you're talking about before you look at your answer choices, then evaluate every answer choice to arrive at the best possible answer.